Let's begin with question number 3 of this paper. Let's move it to a whiteboard, please. Okay, let's read and try. So given that k is 1 over third 3 or root 3, and that p equals to 1 plus k or 1 minus k, expressed in its simplest form, the third form of p. Okay, let's try to do that first. So p equals to 1 plus k or 1 minus k. Then here we substitute back 1 plus 1 over root 3 over 1 minus 1 over root 3. So because there are like a lot of fractions over fraction and things like that, it's good to eliminate that by multiplying by a suitable factor. Like a suitable factor means essentially we're just multiplying by 1. So that means because the factor is occurring on the numerator and the denominator, so you can just multiply by root 3 like this. Therefore, this would simplify to 1 times this, so root 3, then root 3 times this becomes plus 1. This denominator cancels out. You notice that? And this one likewise, this time this is root 3. The one this side, if you multiply, becomes minus 1. So in other words, just to find the value of p, we need to evaluate this third. So what do they mean by simplest form? So when they say simplest form, means for a third, it means that there must be the denominator should not be a third. Denominator must have no third. So how do we do that? So we do a technique called rationalize the denominator. Okay, to rationalize the denominator. Okay, let's multiply by the conjugate. To do that, the conjugate third need to be multiplied. What is the conjugate? So let's give a small note here. That means a plus b root c generally, and these ones are conjugate thirds of each other. Conjugate thirds, a minus b root c. Just change the middle one to minus la. So basically we say, okay, this is the most general form that's used. And let's do that. So let's multiply by suitably based on the denominator, not the numerator. So root 3 plus 1. So the conjugate for the denominator is root 3 plus 1. And then now it's just a matter of expanding this out. So root 3 plus 1. And root 3 plus 1. Okay, it's going to be a square of the whole thing. But on the denominator, what happens is we use the identity a square minus b square. It means something square minus something square. What's that something? The first one is root 3. Second one is just 1. So root 3 minus 1 whole to the square. When we're using the identity, so always we can use this famous identity of difference of two squares. So x plus y, x minus y equals to x squared minus y squared. If you can slowly write and check, you realize that x here is taken as root 3 and the y is taken as it's taken as positive 1. Okay, root 3 and 1. So let's do the remaining part. This part, so this times just, so we're going to write in the next line. So root 3 times root 3 is 3. Then root 3 times 1 is plus root 3. And then 1 times root 3 is plus root 3. Everything from the first bracket multiply with everything from second bracket individually with the signs. So plus 1 like that. So 4 terms, 4 combinations. So it's resulted there. So the denominator becomes root 3 squared is just 3. This is 1. 3 minus 1 like that. Let's simplify within the numerator. For example, this is 2 root 3 plus 4. 3 minus 1 is 2. Separate out the thirds like that. The fractions, sorry. To the then plus 4 over 2. And finally, we get the answer for p in its lowest or simplest form, which is root 3 plus 2. Okay, root 3 plus 2. This answer. Okay, let's do the second part here. Okay, the second one. So we need to calculate p minus 1 over p. Okay, to do this, we use that the value that we got. This is p. So in other words, let's write something like this. Okay, then so 1 root 3 plus 2 first minus 1 over bracket root 3 plus 2. So the conjugate for this is different because it's the denominator here, so we need to rationalize it as per the reasoning before. So we need to multiply by, see, either way, let's use this way, yeah. Actually, rewrite this better. That means I change the order for this one because the bigger number like to deal negative numbers means we can do that. 2 plus root 3 like that, change it to 2 plus root 3. So the conjugate third will be, even if you did that way, you'll get the same thing. Okay, just making it more positive. Okay, please take note. 2 minus root 3 is third. Okay, let's simplify all of this. So root 3 plus 2 minus, the numerator is just the same thing. So 2 minus root 3, let's put a bracket because the negative number here. So here we do this a little multiplication. 2 times 2 is 4, like that. 2 times minus root 3 is minus 2 root 3. Root 3 times 2 plus 2. Oh, sorry. This is another way of doing it. I'm multiplying out 1. Okay, let's do it this way. This time just to get a flavor. I didn't plan that. I just done the difference of 2 squares. But somehow I ended up doing this. So minus root 3 times 3 is 3. Or you could have just done alternately. Just scribble at the side there. So you can see this. Thirds normally has this difference of 2 square trigger to rationalize the denominator. Taking the x this time as 2 and the y as root 3. So x plus y, 2 plus root 3, x minus y, 2 minus root 3, their product will be x square minus y square, which is 2 square minus root 3 whole thing square. So 4 minus 3 or just 1. Let's take note that. So simplify to 1. So here likewise you can see this and cut. This 4 minus the 3 becomes 1. So either way, we arrive at the answer now almost. So just write it nicely. Over 1 is no effect. 2 minus root 3 like that. So now you're going to open up the brackets, multiply the signs. Then one last simplification. Root 3 plus 2 is minus 2. That one is plus root 3. Minus and minus is plus. Now again, these two things cancels off. We cut. So root 3 plus root 3, the answer is 2 root 3. Okay, for this part. Thank you.